kiddos, welcome back. Today we're talking about Chapter 1, Section 2, Day 2. And we're going to spend some more time on that segment addition postulate we talked about yesterday, okay? But first, we have a few definitions to cover. Construction is a geometric drawing using specific tools like a compass or a straight edge, and we'll work with those later. Okay, so now let's jump back in to our segment addition postulate. So we can find the segment addition postulate to solve a missing length, but we have to remember to do 3 steps first. 1, we have to set up the equation. Step 2, we have to substitute in the things we know. And 3, we have to solve it. Okay, so let's do an example together. If I have a segment C, F, and T, and I know the distance between C and F is 23, and I know the distance between F and T is 35. So first thing we have to do is we have to set up our equation using what we did yesterday, okay? So first chunk plus second chunk equals whole thing. So we have the distance between C and F, that's why there's no line over top, plus the distance between F and T equals the distance between the whole thing CT. Okay, so that's step 1, that's setting up. That's what we know, that's the segment addition postulate. Step 2, we have to substitute in what we know. Well, we know that the distance between C and F is 23. So instead of writing CF, I'm going to write 23. We also know that the distance between F and T is 35. So instead of writing FT again, I'm going to write 35. And since we still don't know what CT is, I'm going to leave that there. So we substituted in everything we know. Now, step 3, we gotta solve. So we're gonna add 23 and 35 together and get 58. And that is the distance between C and T. Okay? So what if it looks a little different? What if I have the whole distance but not one of the parts? So let's say that we have a segment where there are points F, D, and G. And we know that the distance between F and G is 36. And we know that the distance between F and D is 21. But we don't know what DG is. Well, we can still find it using the segment addition postulate. So first things first, we have to set up. Okay, so first chunk plus second chunk equals the whole thing. So our first chunk is the distance between F and D, plus the second chunk is the distance between D and G, equals the whole thing from F to G. Okay, so step 2, we have to substitute in what we know. We know that FD is 21, so instead of writing FD, I'm gonna plug in 21. Plus, we still don't know what DG is, so I'm just going to leave that as DG. Equals FG, which we know what that is, it's 36. So just like we did in algebra, this is our variable. If you take the DG out and imagine it's an X, we can solve it. So, since we want to get everything away from our variable, we have to subtract this positive 21 from both sides. These cancel, and so on this side we're left with a positive DG is equal to 15. Okay? Let's do some more examples. So if I had another segment between M, Q, and T, where the whole thing is 22, but the distance between M and Q is only 15. So, first thing we have to do is we have to set up, just like the segment addition postulate would tell us. First chunk plus second chunk equals whole thing. So, the distance between M and Q, which we're talking about the distance, that's why I'm not putting a line, plus the distance between Q and T equals the whole thing, the distance between M and T. Okay, that's our setup. Step 2, we have to substitute. We know what MQ is. We know that's 15. But QT, we don't know yet. So I'm going to leave it as QT. And MT is 22. So just like the last one, if we pretend that this QT is just an X, we can subtract 15 from both sides to get our variable all by itself. And we can see that QT is equal to 7. All right, last one, but this one's going to be hard. So let's say we have another segment between A, B, and C. And we know that the whole thing is equal to 23. But the distance between A and B is X plus 5. And the second chunk is 3X minus 2. We're going to handle this the same way. Okay, step 1, we got to set up. First chunk plus the second chunk equals the whole thing. So we have the distance between A and B, which is why I'm not putting a line over it, plus the distance between B and C equals the distance of the whole thing between A and C. Okay? Step 2, we got to substitute what we know. AB is now X plus 5. BC is now 3X, so plus 3X minus 2 equals the whole thing, and AC is 23. Okay, so step 3, we gotta solve. First thing I wanna do is I wanna combine like terms. I see a 1X here plus a positive 3X here. 1 plus 3, that gives me a 4X. And we still have our plus 5, and we still have our minus 2, and that still equals 23. Okay, so if we take, we'll leave our x's alone, but these two are like terms. So if we have plus 5 minus 2, these cancel out to plus 3. So we have 4x plus 3 equals 23. Now that's starting to look like algebra we've already done. Move over here, we have 4x plus 3 equals 23. And just like in algebra, we want to move the furthest from the variable to the closest to the variable. So since 4 is touching the variable, we want to go out here to this 3. The opposite of plus is subtraction, so we're going to subtract 3 from both sides. These are going to cancel. So we have 4x equals 23 minus 3 is 20. And now we want to get x alone, and since it's being multiplied by 4, we have to divide it by 4. So we divide both sides by 4. The 4's cancel. That gives you x is equal to 5. And that is your final answer. But if they asked what is x here, but if they asked what is AB, you'd have to plug x back up into one of these equations if you wanted to know the length of AB or BC. But we'll do that another day.